Hello everyone. In this course on geophysical exploration methods, we are going to see very broadly the different methods of understanding the Earth's subsurface by deploying some geophysical investigation tools. Right. What are the different tools which are available for us to do this? Before going into the actual methods, why do we need to go for geophysical methods? So here is a question, right? In this case, there are number of regions that are available for you, maybe within a urban region or in a semi-urban region, to recharge groundwater, right? And ideally, the location that is going to be chosen for recharging groundwater should consist of sandy formation, right? So, to identify such ideal locations, right, what are all the various tools that can be used? The tools which we are going to see during this course can be used to answer this question. Another question can be on, right, groundwater got contaminated. Is the contaminated plume stays at the same place, or let us imagine we have gone ahead for remediation of groundwater that has been contaminated. Is our remediation process working well or not? That means the remediation takes place below the surface of the earth. How can we answer this question? We will have the answer at the end of this course. Another case which is related to geotechnical, right? We may be interested in assessing the subsurface conditions rapidly before the commencement of such major infrastructure project. As you see in this picture, right, an elevated corridor is coming up, right, even before the DPR, right. We need to understand what is the subsurface. That is going to very much relate, that is going to very much control the cost of the project and also the structural design. So how can we answer this question? So we have seen three questions. Couple of, one was on groundwater, very much related to hydrology and water resources engineering. The second question was remediation on remediation of contaminated groundwater, that is related to environmental engineering. And the third, that is what we see here, is very much related to geotechnical engineering. So how can we get answers to these questions? I hope at the end of this course, those who are attending this course during this semester or during this term will be able to answer all these questions, right? What are all the objectives of this course? This course is aimed to introduce you the physical properties of the earth and application of different techniques for understanding the subsurface. And once if you can understand the subsurface, we can understand about whether you have plenty of groundwater or not below the surface of the earth, whether the conditions beneath the surface is suitable for major constructions, or similar to the second question we had seen, if you are going ahead for remediation of a contaminated groundwater zone, whether your remediation process is working well, or you may be looking for an ideal site for locating a landfill, whether the site is ideal, meeting to the criteria. This is related to environmental studies, right? So this is the objective of this course. So in this course, but let us remember very well, we are going to not see the entire A to Z of geophysical, but literally we are going to see different methods, but we will not be deep diving into any of these methods, right? Because it is a condensed course wherein you will be exposed to different techniques that are available for us to understand the subsurface, which means each and every method we will look into some fundamental aspects, right? Then how can we obtain the data, deploying some instruments, how the data obtained can be interpreted, and what are all the applications of a particular method. This is what we are going to see, but we are not going to deep dive into the different methods of processing the data. How are we going to carry out inversion of the data, which is known as inverse modeling, Though I will touch upon that, we will not be looking into them in detail. Right. Now, coming to the course objectives, what are all the course objectives? Course content. Right. Course content I have broadly divided into these 6 topics. One is some general, that is what we are seeing today and maybe in the next class. Then the second is electrical methods, third is gravity and magnetic, fourth is seismic methods. All the other methods I have put them together as one chapter. Lastly, we will be doing a couple of lectures on well logging methods, which means we are covering almost all the methods that are available for an engineer or for a scientist to understand about the subsurface in general. Very broadly, we are going to see the different methods. And today, we are very much talking about the sustainable development and also on sustainable development goals formulated by the United Nations. So, here is a study carried out by the Society of Exploration Geophysicists, wherein they try to relate how geophysics will be able to attain sustainable development. There are 17 goals. They have related how to tackle each and every goal. Geophysical methods can be used. For example, no poverty, right? How geophysical methods can be used. So, geophysical methods can help us to understand whether there is going to be any natural disasters or natural hazards. If there is going to be any natural hazard, how we can carry on with the investigation, what are all the remedial measures can be taken, geophysical methods can be applied for that. So, in the same way, they have related how geophysical methods can help us to understand all the 17 goals as you see in this figure. So, thus the geophysical methods which we are going to see during this course actually help us to attain sustainable development in with respect to all the 17 goals formulated by the United Nations. Now, these are the books which you may follow apart from the lecture notes which you are going to get from the NPTEL site. So, I will be following mostly these books and also some references, but plenty of resources are also available in the website, and different agencies are which are responsible for conducting geophysical studies have put up lot of information in their website too, as you see in this slide. What exactly is geophysics? Geophysics is nothing but the study of the earth by quantitative measurement of physical fields. That means we are trying to understand the earth by measuring some of its physical fields. Right. Application of the principles to study the earth and also today increasingly other planets, right? What we search in other planets, though in some planets we have gone and landed, for there are several other planets we are unable to go nearer to that. So, we try to deploy some geophysical tools to understand whether that planet can have some life, whether it can have water. We deploy some geophysical tools to understand that. And the geophysical methods are applied to wide range of investigations for the study of the entire earth. Right. Today we are able to understand about the earth and movement of plates in the earth's surface. All is made possible only by geophysical investigation methods. It is truly a interdisciplinary subject comprising of all this, right? Apart from that, there are many other. So, it is a interdisciplinary subject. As you can see in the title itself, it is geo and physics, right? Geo and physics coupled with a lot of mathematics, right? Geology, hydrology, water resources, plenty of expertise are necessary to carry on with the investigation using geophysical methods. And let us see something in general about the background of this subject. It is in fact one of the very old subject. Why it is a old subject? Because whenever an earthquake occurs, we are really puzzled and very much worried. So, people have started working on aspects of geophysics mainly to see whether we will be able to predict earthquakes. Still research is going on, still this question has not been solved or answered, right? Only because of this the subject gained importance earlier. Subsequently, from 1500s, some work has started on the applications of Earth's magnetism as well as Earth's gravitational. Sometime during early 1900, a seismologist made use of geophysical investigations to understand about the interior of the Earth. Today we talk about Earth has got about 35 kilometers, up to 35 kilometers we have a crust, then we have mantle, then we have core at the center of the Earth, whereas the deepest well drilled so far is not beyond 15 kilometers. But we are talking about what is there at 6,000 kilometers below the surface of the Earth. How do we tell about all these things? We have understood that only by seismological evidences. That means geophysics helped us to understand about the interior of the Earth. Then by 1960s, we have attained rapid progress in geophysics that helped us to understand about the theory of plate tectonics. That means the present Earth was initially as one plate. The rest of the Earth was covered by water. Subsequently, the plates have moved and they are today at their locations. But even now, the different plates are under continuous movement. In fact, geophysicists are able to understand how these plates are moving, where are the plate boundaries, what happens along the plate boundaries. We are able to answer all these questions only by geophysical tools. Lot of development has was attained sometime during early 20th century, especially because of the development we had gone through in the instrumentation as well as computer science and information technology. This has helped the geophysicists to rapidly progress in this area of research. After having seen something general about geophysics, what is geophysical exploration, right? That is, this course is on geophysical exploration methods. What is geophysical exploration? A person is standing on the surface of the Earth. There are a lot of questions he has. He may be a geotechnical engineer, or he may be a groundwater resources engineer, or he may be a geologist. Each one may have a different question, right? The commonality among them is what are the different types of rocks present beneath the surface. How can we answer that? So, answer to that is possible by geophysical exploration. So, in geophysical exploration, we are going to deploy some tool, and the signal that is generated from that instrument will enter into the surface of the Earth, go beneath the surface of the Earth. It may come back to the surface of the Earth again, which is received. So, there is a source and there is a recorder. From the signals which we receive at the surface of the Earth, we try to understand about the subsurface. This is what is very simply geophysical exploration, right? So, at the end of the exploration, so the Earth was having such a complex structure below the surface. We are able to understand such a complex structure by carrying out some investigation, geophysical investigation, that has produced the image which you see here. Using that image, we try to understand the different formations that are present below the surface of the Earth. So, precisely how can we define geophysical exploration? So, the study of subsurface conditions of the Earth. How? By measuring. We are going to measure, then we are going to analyze the measured information, right? And then by analyzing, we are going to interpret the data we have obtained. What for? To understand about the subsurface, right? So, the study of subsurface conditions of the Earth by measuring, you measure and analyze the data which you have received. And what for you analyze? You analyze to interpret the data. Analyze and interpret the data right? How did we measure? The measurement was made by kind of remote sensing. That means you don't go deep dive into the earth, but you are at the surface, right? Make some minimal invasion at the surface. Using that, you try to understand about the subsurface. So it is basically a non-invasive technique. So this is what is geophysical exploration. What I will repeat again, in geophysical exploration, without being in close contact with the subsurface, you deploy some instruments at the surface of the earth, make some investigation, make some measurements. We use that measurements and interpret the values or numbers we have got to understand about the subsurface. So this is what is geophysical exploration, right? What are all the advantages? So very simple. Always I used to say, we undergo medical examination, right? Suppose if there is any flaw in my hand, right? If I get a pain in my elbow, normally we don't really cut and see what is the issue, isn't it? So we are advised for some medical tests. One common test is investigation is X-ray, right? X-rays cannot pass through the thick, dense bones. So using the X-rays, we are able to understand whether there is any crack or fissure in the bone, right? So that is in the same way, we are going to understand about the subsurface. That means we are going to carry out some investigation on the surface of the earth, right? Geophysical investigation is carried out on the surface of the earth to answer something much below. So it is one of the greatest advantage. So there is no need to drill, right? Drilling is very expensive. By drilling, we are able to get the samples of the subsurface. So we are very sure what are all the different types of rocks. But drilling is very expensive. So on the other hand, deploying geophysical tools is much cheaper, right? Then we are able to also understand greater depths. Drilling up to such greater depths is very expensive. Up to few kilometers, can be about 6-7 kilometers of depth can be scanned by geophysical investigation tools. So that is the another advantage. Also, similar to a image which I showed you on the previous slide, we literally get a image of the subsurface, right? That image may be due to different signals, for example electrical signals or from seismic waves. So we get different images based on the physical field which we choose. So we are able to get the literally image of the subsurface, which means we are able to literally see 7 kilometers, 6 kilometers below the surface of the earth by deploying some instruments on the surface, making some measurements, right? We are going to see all of them in detail little later. We are able to understand the nature of rocks and whether the rocks are present below the surface horizontally or they are folded like this. We can answer using geophysical methods. We can delineate locations that have mineral or oil, that can be also delineated, right? So it gives us an indirect way to see below the surface. So these are the greatest advantage. As I told you initially, this is somewhat equivalent to medical examination which we undergo. Most of the medical examination which we undergo are non-invasive. For example, X-rays. So X-rays pass through us, but we don't feel anything due to that, right? So using the image that has been produced using the X-ray machine helps the doctor to understand what is the issue within our body. In the same way, in geophysical exploration method, we are going to deploy some tools to understand something very deep below the surface of the earth. So this is of greatest advantage. Other way to understand the subsurface of the earth is by drilling. But as I told you, drilling is very expensive. What are all the different applications of exploration geophysics? Initially, geophysical exploration methods, right, that is why I put as conventional applications, were restricted to searching for some economic minerals, maybe gold or copper, lead, zinc, and so on, and for oil exploration, right? Today, hydrocarbon is one of the important resource. So initially, the geophysical methods were broadly used to explore for minerals and oil, right? Which means we need to understand the subsurface geological conditions as well as geological structures. Subsequently, the methods were used to understand the presence of groundwater below the surface of the earth. In the case of other applications, important applications are in environmental monitoring. What is the environmental impact? For example, there may be a landfill located in a city. Landfill is a region where we dump our domestic solid waste. What is the impact of this dumping of solid waste in a landfill to the surrounding area? One of the common impact will be movement of contaminants along with the water. Groundwater may contaminated around the vicinity of landfill. We can investigate how far groundwater has got contaminated, what are all the remedial actions that can be taken. Then archaeological investigations. As I had mentioned previously, to understand other planets. So, we deploy some tools. Chandrayaan went and landed the moon, but it had some tools to understand the surface of the moon as well as to some distance beneath the surface of the moon. So, today these techniques are often used to understand other planets too apart from the Earth. And as I have been telling, we get the image of the subsurface as you see in this diagram, right? Once if you have the image, you can play with that to come out with sections in different directions as you need. So, it has provided a way to understand what is present below the surface of the earth. So, most of the methods are restricted to some few hundred meters, that means upper zones of the surface of the earth. And there are other methods, as I told you, seismic methods, we can understand up to 6-7 kilometers below the surface of the earth, right? In fact, using seismic methods, we have understood the interior of the earth. And this gives you the broad list of applications, as I told you, mostly in mineral and oil exploration, groundwater exploration, and environmental investigation, right? In civil engineering purpose, to understand about the ground stability, understand about the subsurface geological conditions. The elastic modulus can also be indirectly estimated using geophysical tools, dam safety, and foundation data characterization for major infra projects can be done, and also in geohazards, right? Also to understand and about the earthquakes as well as earthquake mitigation, right? Presence of collapse structures below the surface of the earth. There can be large cavities, caverns. Where are they located can be estimated by or can be identified using geophysical tools. Very much on urban mapping, right? Especially to understand where are the utilities. That means buried pipelines, drainage lines can be identified using geophysical methods, deployed very often to understand artifacts, buried artifacts, archaeologically important sites, right? Also used in forensics for defense purpose, also to understand about the unexploded ordnance below the surface of the earth, the bunkers below the surface of the earth. So, these are some of the common applications of geophysical methods today, right? Apart from understanding the earth's subsurface. So, here we would have understood the broad applications. I have just listed out whatever that occurred to me, but beyond that also there are plenty of other applications of geophysical methods. Right? Now, let us slowly deep dive into the subject. In this page, we will have a look into the different methods, broad and very important methods of understanding the subsurface. Very broadly, the methods can be classified as passive methods and active methods. What are passive methods? In passive methods, measures naturally occurring phenomena beneath the surface of the earth. What is naturally occurring? For example, gravity. Gravity is there everywhere around the earth. So, if you measure the gravity, then that method is called as passive method. What do we mean by passive method? That means whatever physical phenomena that occurs naturally, when we measure that, then it is called as a passive method. Then what is a active method? In active method, we are going to transmit some signal, as we had seen on the previous page. This is the surface of the earth. From here you are going to transmit some signal. That signal goes in and gets back to the surface. Here you are having some receiver and measuring that. Then this method becomes a active method, because we had some source. From there we have generated some signal. That signal has gone in and returned. That was picked up by us, right? And we analyze the results which was received at the receiver. If so, that method is known as a active method. That good example for active method is a seismic. But you may wonder, seismic method is also there as a passive method. So, what is a passive geophysics? In passive geophysics, we are going to make use of naturally occurring phenomena. Shock waves are also generated during earthquakes, right? If you make use of the shock waves that got generated naturally during earthquakes, then it becomes passive seismic method. If you generate shock waves and make use of that, then it becomes active seismic method. Hope you can understand the difference between active and passive. So, these are all the methods that are listed down here. Passive method, for example, electrical. Electrical is also passive. That means naturally beneath the surface of the earth, the situation may be such that there is some production of natural electrical potential. So, if we measure that, it is a passive electrical method. On the other hand, here in active, this is the surface of the earth. We may pass current by connecting a battery. Current may be passed in. The effect of that may be studied by us. Then it becomes a active electrical method, right? So, these are some common examples of passive methods and active. What we are going to measure in all these methods? What is exploration? In exploration, I told you clearly, in exploration we are going to measure something. The measured values should help us to understand about the nature of material that is present below the surface of the earth. So, here in these two slides, I am just showing you what we are measuring, which physical property of the earth control the measured properties. That is what we are going to see. So, can we have some examples? Let me say I am going to measure the resistivity of the earth. Right? I am measuring the earth's resistivity. What is the property of the earth that is going to control the earth's resistivity? Maybe electrical conductance. Obviously, electrical conductance is going to control resistivity. Electrical conductance depends on what? Electrical conductance depends on the property of the material. For example, if the subsurface of the earth has got ore of copper, then the earth is going to be a good conductor. Beneath the surface, you have a very thick carbon material, maybe coal, which is a poor conductor. So, measured property is Earth's resistivity. The property that controls the resistivity is conductance. Conductance indirectly helps us to understand about the nature of material present below the surface.